Welcome to the project demonstration of Electrical Vehicle Battery Management BMS with charge monitoring and fire protection using Arduino Uno. So here the main application of this project is generally when we are like powering up the EV vehicles using the battery packs, then there are the three main things we need to check while we are utilizing the battery packs. So one is voltage protection, and the next is the current protection, and next overheating protection. Overheating may occur due to the heavy load or heavy voltage, or is there any leakage of short circuit current. So due to this, the overheat it will be occurred. So we need to provide these three cases protection to the battery pack. So that is called the BMS, as a battery management system, continuously monitoring the battery voltage levels, current levels and temperature. Along with that, in this version we are added the extra feature of like SOC, SOH calculation also. So SOC nothing but state of charging, which is used to check the battery charging levels, whether it is charging in normal level or slow or faster manner. So as we are providing the 1 amp of current to the charging of this battery pack, then if we provide the 1 amp of current, it has to increase the voltage for respect to the certain times. So if it is not reached that level, then it will affect the SOC, and that will be monitored on the LCD screen, so that the user can know about the battery status, if is there any leakage of current is occurred, or the battery life, or is there any short circuit occurred inside that. So that will be continuously monitored by the microcontroller, so Arduino Uno we are using. And then whenever this battery voltage also measured by this voltage sensor. So here using the voltage sensor along with this current sensor. So if the load increases, that will be continuously monitored by this current sensor, and battery level of this voltage in terms of measured by this voltage sensor. And in these two cases, the system will provide us audible alerts if is any fault occurred. Coming to the voltage, if the voltage is less than 8 volts, as we are using a 12 volt 12 volt 1.2 ampere of battery pack we are using, and this battery pack consists of 3 cells. In that each cell is 3.7 volts 1200 mAh, that's 1.2 ampere. These three are in series, so we'll get 12 volt 1 amp 1.2 ampere of current. And when it is less than 8 volts, then the system will indicate the low voltage, and that will be alert through this buzzer as audible alerts and a visual alert on the LCD screen. And these two buttons are used to charge a battery pack in the normal charging and fast charging manner. And the next mainly power source we are providing to this system is 230 volts AC inputs. And one more thing is overheating. So with the help of this temperature sensor, we are going to continuously check the temperature of this battery pack. Whenever it crosses the 40 degrees centigrade, then it will provide us audible alerts, as well as a coolant fan will get switched on to control the temperature over here before the fire getting accident. And coming to the flow of the power, so we are going 230 volts AC input to the transformer, which will step down the 230 volts AC to 12 volts of AC, and that will be converted into the two outputs. One is the 12 volts of DC, that is charging of the battery pack through this relays, as we can see these wires, and the next 5 volt output. So the 5 volt is the operating voltage of our system, which will take 12 volts DC input and provide us a 5 volts DC output with the help of this 7805 voltage regulator. So there are the stages of transformation, rectification, filtration and regulation. So these are the 4 stages of regulator power supply units. And once we provide the 5 volts power supply, it start reading input from the current sensor, this is the voltage sensor and temperature sensor. Based on these abnormalities, it will provide us the audible alert through this buzzer board, and the state is continuously displayed on the 16:2 LCD screen. And if the temperature increases, it will on this fan with the help of this transistor board. And next, these are the relay boards to control the charging to this battery pack. Let us see the demonstration. So once we on the system, then we can see the welcome message on the LCD screen, and it will start continuously measuring the voltage. Right. Yeah, so we set the voltage limit of 10 volts only for this lithium ion battery pack. If it's a dry acid, it's 8 volts. Now just we can on this by selection this one. Right, so it's connected to the fast charging. As you can see, the voltage slowly increasing over here. So once the voltage reaches 11 above, then automatically it will be switched off. Means it will give the low signal to this relay board, and we can see the load as to. So now the motor which are connected over here, which is nearby 1 amp. So we are getting the 900 milliamps of current is consumed by this one. and SOH values are continuously measured. SOH nothing but whenever the load connected, if the load is connected and then the current is not sufficient driven to the motor, then it will get the affect this SOH values, so which will show the state of health. And the next, just we are increase the temperature. So when it crosses the 43 degrees centigrade, then we will get the audible alert, as well as the coolant fan gets switched on to protect the battery from overheating. Right. So here for fast charging also we can check that. So when we select that, it will show you the fast charging on this, and the screw release gets switched on. And if you can place the voltage fault also, right. So when off that, then you can see the low voltage. Once it reaches to the above 11 volts, then automatically this relay will get switched off. Thank you.